Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, we are still working on the trig substitutions and how best we can use those, techniques to solve some trig integral problems. So today we are looking at other interesting examples, and we have this beautiful problem that we want us to confront today. Let's see how we would solve this problem. Let's get going. And at this point, if you have not subscribed, please do so. Like our content, share with your colleagues, with loved ones. So let's help spread and demystify, the myth around mathematics. So let's get going. All right. So, looking at this, expression in the denominator, which is x squared, the square root of x squared minus root a squared. We said that this is associated with a substitution, or probably the best substitution for this particular, expression is what we mentioned. That is what is, we said is what is x equal to what? A, or remember, it's a what sec or theta, okay? And the whole point of you doing this is trying to, if you look at it from one domain or from one region, and we saw that to solve this problem, it to be very cumbersome. So it's better we transition from one point to the other. It's just to have a different perspective of solving the problem. So we want to switch from x to the theta, okay? Or you want to switch from the x community to the theta community in order to solve the problem. Okay, very good. Let's get going. Now, in this particular problem, we may want to do some restrictions, right? Remember that we said that our theta should lie between where? Remember, our theta should lie between 0 to 90, or from where? Or from 80 to what? Or 180 to 270, okay? That's what we said. Now we need our dx. Well, now what is our dx? We need our dx should be what? X what? Should be a tan what? Tan theta sec or sec theta dx d theta. Okay, very important. Let's take note of that. Very important. So with that being said, our root of x squared minus x squared. So by doing the proper substitution, our x, we know our x to be what? To be a sec theta. Okay, so we just do our substitution, and by doing that, we're going to have what? A squared sec squared theta minus 1. And when we simplified, we should have what? X squared sine theta tan squared theta. Okay, remember, this is an identity that we learned earlier on. And in previous episode, we saw quite a number of examples where we kind of look at other interesting things that we can use to solve problems. So you may want to revisit them. Okay, very important. All right. Now, therefore, when we look at our problem, now we've kind of more often than not simplified almost everything. So let's look at the problem, and then we kind of solve it straight away. Now, what is our dx? From here, we see that our dx is this, okay? So our dx is what? Is a tan theta sec theta, okay? D theta, okay? Now, what is our root of x squared minus a squared? And then we had what? From our analysis over here, we had this result, okay? So we had a tan theta, okay? Very good. So which case we can do some cancellations, right? So we see that this quantity will cancel this, okay? So you will only be left with what? Sec theta d theta, okay? Is that okay? Now, if you really kind of recall some of the integral of some integrand like sec theta, we kind of when we do that, we're going to have the natural log of sec theta plus tan theta. Then because this is an indefinite power, we need to add a constant, the arbitrary constant c, okay? Okay, and then we said that this particular solution is not unique, okay? Because it can have multiple solutions. If C is 1, you have one solution. If C is 2, if C is any value, you can have another solution. So let's take note of that. Now, remember that the problem that we're giving in was in the X community. And because we wanted to borrow that idea from the theta community, so we went to theta and said that theta, please, we have this particular problem, we want us to solve it. Please help us. Now, if theta now get a result, theta has to come back to X and say that, please, this is the solution to your problem. So we have to go back to X, okay? And how do we do that? We have to play some smart here, okay? Very good. So now what is sec per trig? With sec theta, we said that sec is always what? Now, over here, remember we have from here, we can easily deduce our sec, sorry. Our sec theta will be what? Will be X over A, okay? And remember that sec theta is always what 1 over cosine theta, okay? So in which case we want to use the SOHCAHTOA. Remember the SOHCAHTOA. If you remember the SOHCAHTOA, you remember the SOHCAHTOA, the cosine. And now what will be my cosine? Now I need to draw. Okay? So we need to draw to be able to find. So remember that the cosine is always what? Cosine is always k, okay? So k, it will be what? The adjacent over the hypotenuse, okay? So from here, we see that, our adjacent will be A, and then our hypotenuse will be what? Will be X, okay? Our adjacent will be A, this your angle, then your hypotenuse will be X. And when you do that, you should be able to have this. Okay, very good, very good. So we need to find um tan tan theta, and tan theta is TOA, okay? So TOA will be opposite over the adjacent. Now, what is your opposite? Your opposite is what? Root of x squared minus what? X squared all over your adjacent. Your adjacent is what? Is your A, okay? Very good. So now our problem is solved, right? Our problem is solved. So we have that, okay? So from the above discussion, we have that the problem that we're given can have its solution as lane of remember we said that we had sec to be what? Sec was as what? X over A, okay? And then our tan theta should be what? Tan theta, that's what we had it here. We had it to be what? The root of what? The root of what? X squared minus x squared all around over A plus C, okay? Now, you can simplify this. By simplifying, if you simplify this further, we should be able to have x plus what? The root of what? The root of what? X squared minus a squared plus, no, minus, okay? So the minus the natural log of a plus the constant c, okay? So if you simplify this a bit. Thank you so much. And at this point, if you have not subscribed, please do so. Like, comment, and let's share this content with our colleagues, with our loved ones. Let's help demystify the myth around mathematics. Thank you so much. Stay blessed. Bye-bye.